all once again. Today we're going to discuss about the chapter Alcohols, Phenols and Ethers, chapter 11 of NCERT chemistry. So, alcohols, phenols and ethers. So before moving to this, I am Ravina. Welcome to my channel Chemflix, and if you are new to this channel, please click on the subscribe button and also click on the notification bell icon so that you will get all the notified about all the videos that I am going to upload. And also please like this if you found this video useful, and also share among your friends. Okay, so without wasting much time, directly we're going to what is this alcohols, phenols. Okay, so let's start. So alcohols, what do you mean by alcohols? Already in 10th പഠിച്ചിട്ടുണ്ട് alcohol, the functional group of alcohol. What do you mean by alcohol? 10th class already discuss ചെയ്തിട്ടുണ്ട്. So ഈ alcohols എന്ന് പറയുന്നതിനകത്ത് there you can find a compound containing CO single bond. Okay, there you would get a compound containing CO single bond. Okay, CO single bond. So I will show you a particular representation of alcohol. So R, this one is R, okay, R, C, CH2, okay, OH. Okay, there you can see this one, okay, this one is our C, okay, C, and this one is our O. There you can find CO single bond. And the functional group present in alcohols and phenols is OH group. Okay, I will draw you a phenol. I will draw you a phenol. Okay, this one is phenol actually. This one is phenol. Okay. So this is a benzene ring and an OH group is attached to a benzene ring. Then it can be called as a phenol. So the functional group common to this alcohol and phenol is OH group. And this OH group, we can name this OH group as hydroxyl group. Okay, hydroxyl, HYDROXYL, hydroxyl group. Okay. Now we are going to see this ether. Okay, I'm going to tell you what is this ether. Okay, so this is the general formula of ether. You can see here in ether the oxy group. There you can find an oxy group. Okay, oxy group. So ROR dash. So this one is actually a ether. I will tell you how to name this ether lately. Okay, in the next slide. Okay, so in alcohols the OH group is bonded to an alkyl group. I already we discussed this OH group is bonded to an alkyl group. That means you can see a C single bond over there. So the general formula is ROH. Okay, but in phenols the OH group is bonded to an aryl group. Okay, this one is called aryl group. Okay, this benzene ring. Okay, aromatic group can be called as an aryl group. Okay, this one is phenol, so this one is aryl group. So this aryl group, so we can general formula of phenol is AROH. Okay, so that's all about this slide. Moving to the next slide, classification of alcohols. How can you classify this alcohol? So depending upon the number of OH group, okay, how many OH group is attached to a particular carbon or in a compound, how many numbers of OH group or hydroxyl groups are there, we can classify this alcohol into monohydric alcohol, dihydric alcohol, trihydric alcohol, polyhydric alcohol. So I'll give you an example. For example, we are talking about butanol. Okay, I'm going to tell you about butanol. So you can see here, this one is the structure of butanol. It is CH3, CH2, 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 OH. There you can find a one OH group. Okay, only one OH group. So it is an example for monohydric alcohol. For example, I'm going to tell you about the ethylene glycol. For example, CH2, CH2, OH, OH. Okay. So here you can find the number of OH group is there. You can find two hydroxyl groups there. Therefore, you can name it as it is an example for dihydric. Okay, this is ethylene glycol. It is the common name ethylene glycol, or otherwise the IUPAC name is ethane 1,2-diol. Ethane 1,2. Okay, whenever you are separating the words and numerics, then you have to put a dash line. Okay, or a hyphen there. So ethane 1,2-diol. Okay, diol. Okay, because there is two alcoholic group. Okay, so the naming. Okay, about the naming, Okay, oil is the suffix there we need to add with an alkane. For example, if I am going to take a butanol, then the name will be like this, butane plus oil, and we have to remove this E. The nth E you have to remove, and the name you will get just butanol, B-U-T-A-N-O-L, butanol. Okay, so depending on the number of OH group, you can classify this alcohols into monohydric alcohol, dihydric alcohol, trihydric alcohol, and polyhydric alcohol. Okay, now we're moving to the next slide. The classification of alcohols based on the sp3COH bond. Okay, sp3COH bond. sp3 means single bond. sp3 single bond. Okay, COH bond. Okay, we are dealing with this. Then you can classify it into primary, secondary, tertiary alcohol. I will tell you what is exactly this primary alcohol, secondary alcohol, tertiary alcohol. Okay, so here, look at here. So, see, suppose I am taking ethanol, CH3CH2OH. CH3CH2OH. So, here this OH group is attached to this carbon containing 2 hydrogen atom. Okay, I am going to elaborate this. So, CH3CH okay, CH3CH2OH. Okay, so this OH group is directly attached to this carbon containing 2 hydrogen atom. So this type can be called as primary alcohol. This one is called primary alcohol. Now moving to the second example, that is I am going to add this CH3, CH, again there is a substituent here, that is CH3. Then you are going to add this OH here. So you can see here this carbon, okay. This carbon which is attached to another one CH3 methyl, okay, this one is methyl group, and there you can find only one hydrogen is attached to this carbon, and this type can be called as secondary alcohol. Secondary alcohol. Moving to the tertiary alcohol, CH3, C, CH3, CH3, OH. So here you can find this carbon is attached to 3 other methyl groups. This one is the first methyl group, this one is the second methyl group, this one is the third methyl group, and there is no hydrogen substituted to this carbon atom. So this can be called as tertiary alcohol. Tertiary alcohol. So this one is primary, we can write it like this, okay. Primary, this one is secondary, this one is tertiary. Okay, so that is the difference. If this carbon, it is attached with this, if there is 2 hydrogen is attached to this carbon and there is an OH group, then you can say it as a primary alcohol, or otherwise CH3OH, this one is a primary alcohol. Okay, this one also primary alcohol, and if there is only single hydrogen attached to this, then it is secondary alcohol. And if there is no hydrogen attached to this carbon OH, okay, this carbon, then it is tertiary alcohol. I think it's clear for you. Okay. So then next, allelic and Venosilic alcohol. So what do you mean by the term allelic and what do you mean by the term Venosilic? Okay, I will tell you what exactly is. Okay, moving to allelic. Okay, allelic. What do you mean by this allelic? Okay, I'm going to change the color of my pen to yellow, so that you can see it clearly. Okay, allelic. Allelic is this type of. Okay. This type can be called as allelic. Allelic. Okay. I will tell you what exactly it is. C double bond C. Okay, this one is C. This one is C. So C double bond C. Then single bond C. Then this OH is attached to this carbon atom. This is what it's exactly called, what is allelic. There you can see this sp3. So, it is a trick that if there is triple bond, then it is sp. If it is double bond, then it is sp2. And if it is single bond, then it is sp3. So, here you can see this one is a single bonded carbon. Okay, single bonded carbon, that means sp3 carbon. Same in primary alcohol, there you can find CH2OH. Okay, CH2OH, and secondary alcohol, there you can see CHOH, and in tertiary alcohol you can see COH. Okay, this one is primary, this one is secondary, and this one is tertiary. Okay, there also you can see single bonded carbon. That means sp3 carbon. That's what the first classification is. Compounds containing sp3COH bond. That is what is called this primary, secondary, tertiary, and allelic and benzylic. In the case of benzylic, I will tell you, benzylic means there is a benzene ring is there. Okay, this one is the benzene ring, and the CH2 is attached to here, and there you can find an OH group. So in both these cases, what is exactly happening here is there is a double bond. Okay. Just a minute. Okay, just CH2OH. There you can find a double bond. Okay, so you can find a double bond and then a single bond, and then to this carbon, single bonded carbon, OH is attaching. Okay, C, double bond C, then a single bond to this OH is attaching. That is actually called allelic if it is aliphatic. And if there is a benzene ring, then it can be called as benzylic. CH2OH, then it is benzylic alcohol, benzyl alcohol, benzylic. Okay, benzylic. The name here is benzyl alcohol. Benzyl alcohol. Okay, so that's all about this. And now we are moving to the compounds containing sp2C single bond OH. sp2 means there you can find a double bonded carbon, and to this an OH group is attaching. So that example is vinyl alcohol and phenols. There you can see the phenol, you know, the common example of phenol, that is phenyl ring is there, and you are going to attach this OH directly to the C double bond C. And also vinyl. So vinyl, here you can see vinyl, that means double bonded C, sp2 carbon is here. This one is sp2 carbon and an OH group is attached to this sp2 carbon, then it can be called as vinyl alcohols. Vinyl alcohols and phenols. Okay, so that's all about this. Okay, now moving to the next slide, we are going to nomenclature of alcohol. Okay, the next slide is about the nomenclature of alcohol. Therefore, about the common name by suffixing the alcohol to the name of the alkyl group. So there is a word root and you have to add YL alcohol to this. For example, I am going to write CH3, CH2, CH2, OH. So that is the compound that I am going to name it right now. So here the word root, you have to find out the word root. How many carbon atoms are here? So the name will be, the word root for this, how many carbon atoms? 1, 2, 3. So it is propane. Okay, propane. So we have to add YL alcohol to this. That means, okay, in order to name this one is the word root, and you have to add YL alcohol to this. Then you will get the name as propyl alcohol. Propyl alcohol. Okay, the name, word root will be prop. Word root will be prop. And you have to add YL alcohol to this. The name will be propyl alcohol. Similarly, butyl alcohol, pentyl alcohol, and so on. Now moving to the IUPAC name, by substituting E of the alkane with the suffix oil, that I have already told you that is safe in the case of CH3, CH2, CH2OH, alkane. You have to name the alkane. The name alkane is 1, 2, 3. Total 3 carbon atoms are there. So it is propane. Okay, propane. And you have to suffix with oil, and you have to substitute this E with the oil. So the name will be propanol. Propanol will be the name. Okay, so that will be the nomenclature of alcohols. Okay. Okay, so the next slide is about the some of the compounds and common names and IUPAC name, as you can see here. Okay, here you can see. So this one is, the first one is about CH3OH. Okay, you are going to find out the common name. The common name, get that you have to find out the word root, and you have to add YL alcohol to this. YL alcohol to this, then you will get the common name. And in the case of IUPAC name, first of all, you have to write the alkane. Okay, you have to find out which alkane is that. Then you have to substitute this E with the oil. You have to substitute this E with the oil. Okay, so let's see. The first example is CH3OH. Okay, so how can you write the common name? So here you will find that the number of carbon atom here is 1. So the word root will be meth. Okay, the word root will be meth. And how can you write the common name? You have to add meth with the YL alcohol, then the common name will be methyl alcohol. Okay, methyl alcohol. And in the case of IU, the alkane is methane, is the alkane, methane. And you have to remove this E with oil. So the name will be, what is the name? Methanol. The name will be methanol. Okay. And now moving to the second example. How many carbon atoms are here? 1, 2. There are 2 carbon atoms. So the word root will be eth. Okay, the word root will be eth, and you have to add ethyl, YL alcohol to this, and the name will be ethyl alcohol. And in the case of IUPAC name, the name will be ethanol. That is, first of all, you have to write the alkane, and you have to substitute this E with the OL, then you will get the name as ethanol. And now to the third carbon atom. Okay, third carbon atom. How many carbon atoms are here? 1, 2, 3. So 3 carbon atoms. So whenever you are naming a particular alcohol, you have to count from this carbon, because this carbon is attached to this functional group. So you have to count this carbon as the first carbon, first 2, 3. So the name will be N-full alcohol, that is the name, and the IUPAC name is propan 1-ol, because here the substitution is happened to the first alcohol, that is propanol, and of course it is common to what is called this propanol. Okay, no problem in that. And but it is the proper way of IUPAC naming. Okay. Now the same content. How many carbon atoms are here? 3 carbon atoms are here. Here the common name is isopropyl alcohol. The common name is isopropyl alcohol. Here you can find out that 1, 2, 3. Okay. This is the straight chain. So you have to, first of all, you have to analyze the straight chain, and this one is the straight chain here. This one is the straight chain, and in this straight chain, second carbon you can find an OH group is attached to this second carbon. Okay, an OH group is attached to the second carbon. So the name will be propan 2-ol. So you have to add, this one is hyphen. You have to add this hyphen in order to join between this numerical and alphabet. Okay, alphabetical word and numerical. Okay, you have to add a hyphen between these two. Okay. Now moving to the next example. How many carbon atoms here? 1, 2, 3, 4. So obviously butyl alcohol. This is normal butyl alcohol, just to show that it is a straight chain. Okay, a normal means it is a straight chain. Okay, normal butyl, and the name will be butanol. Same. The next here number of carbon atoms is 1, 2, 3, 4, and here the straight chain. You can see the straight chain is this one is the straight chain, and this one is the OH group is attached to the second carbon. So butan 1-ol will be the IUPAC name. And again, okay, naming to this, okay, first of all, you have to find the longest straight chain, and the longest straight chain here it is. This one is the longest straight chain, and in this straight chain, first of all, you have to give the number 1, 2, 3. So, which means this functional group, our OH should be attached to the carbon containing the least number. Okay, getting the least number. So this one is the number 1. Okay, this one is number 1, 2, 3. So propanol will be the name. And here in the second carbon, you can see an attachment, that is our CH3 okay, attachment you can see here. So the name will be 2. This one is methyl. Okay, methyl is attached to this. So 2, the second carbon, 2 hyphen methyl, 2 methyl, propan, and in the second first carbon, you can see an attachment here, propan 1-ol. Okay, that is the name. Again, moving to the next example, that is how many carbon atoms are here? 1, 2, 3, 4 carbon atoms are here. So the common name will be, it is a tertiary. Okay, this one is tertiary. So tertiary butyl alcohol will be the common name. But coming to the IUPAC name, you have to find out here 1, 2, 3. Okay, you have to find out the longest carbon chain. I'm going to draw the longest carbon chain here. So this one is the, okay. This one is the, okay, wait. This one is the longest carbon chain, this one. This one will be the longest carbon chain. So the longest carbon chain containing 3 carbon atoms. So I'm going to number it is 1. This one is the 2, and this one is the 3. And the second carbon atom, you can see a methyl group. Okay, CH3. Can you see that there is a methyl group is there? And the second carbon atom, there you can find an OH group is also attached to there. So the name will be 2-methyl propan 2-ol. So now I think it's almost clear for you how to name a particular alcohol and what is the difference between this common name and IUPAC name. Okay, so moving to our next slide. How can you prepare an alcohol? So the next slide, and next we are going to study about how can you prepare an alcohol. So from alkenes, the first method of preparation of alcohol is from alkenes. So by acid catalyzed hydration, that is the first method, by acid catalyzed hydration. What do you mean by hydration? Hydration means addition of water. Acid catalyzed, there is a catalyst is there and this catalyst is acid. So acid catalyzed hydration, as you can see here, there is H plus is there and H plus you are going to add water to this alkene. Alkene, you are going to add this water to alkene. So alkenes react to the water in the presence of acid as catalyst to form alcohols. In this case of unsymmetrical alkene, the addition reaction takes place in accordance with the Markovnikov's rule. What do you mean by this Markovnikov's rule? So Markovnikov's rule says that negative part of the addendum will go to the carbon atom containing least number of carbon atoms. Negative part of the addendum will go to the carbon atom containing least number of carbon atom. So here you can see in water H plus and OH minus is there, and this is our negative part. Okay, this one is our negative part, and negative part of the carbon will go to the carbon atom containing least number of hydrogen atoms. So here in this, which one is the least number of hydrogen atom? This carbon is the least number of hydrogen atom, containing least number of hydrogen atom. So the negative part OH will go to the second carbon atom. So this is in accordance with the Markovnikov's rule. So why you are adding water to the C double bond C group, that means alkene, in the presence of an acid, you will get this type. That is the general formula. This one is the general formula. And you are taking an alkene there. It is according to the Markovnikov's rule. That means negative part of the in addition, the negative part of the addendum, that means the substance that are going to add, negative part of the addendum will add to the carbon containing least number of hydrogen atom. That is Markovnikov's rule. Okay, so from alkenes, how can you prepare alcohol from alkenes? So this one is an alcohol. The name of this alcohol is 1,2,3. So propan 2O. The name will be propan hyphen 2. OL. Okay, the name of the carbon will be propan 2O. So how can you prepare this alcohol? By acid catalyzed hydration. By acid catalyzed hydration. Okay, that is acid catalyzed hydration to alkene. Catalyzed hydration of alkene. Okay, now moving to the next method. Okay, so before that I'm just showing you the mechanism. Okay, mechanism. Here, first of all, what happens here is, okay, I'm showing the entire mechanism. Okay, here and I will explain it. Okay, so first of all, what happens here is H2O, when it comes in contact with the acid, what happens? Hydronium ion is formed. What is this ion? Hydronium ion is formed. And then this hydronium ion, you can see here, hydronium ion, there is H3O plus, there is a plus sign in oxygen. That means this oxygen is electron deficient. And in order to compensate this carbon, there you can see this is sp2 hybridized. That means sp2 hybridized. That means there you can see a pi bond here. Pi bond. What do you mean by pi bond? Pi bond means parallel bonding. Okay. So this one will easily donate the shared electron pair towards this oxygen. Okay. So towards this hydrogen and this oxygen. Okay. What exactly happening here is this one will attract this hydrogen. Okay, and this hydrogen will donate the shared electron pair towards the oxygen, and this one will separate it as water. And due to the donation of this electron to this hydrogen, what happens? This carbon, it attains a positive charge, and thereby a carbocation is formed here. Okay, this species is called a carbocation. In the carbon, there you can see a positive charge, so this species can be called as carbocation. And in order to compensate this carbocation, we are adding this in water. Okay, we are hydrating this alkene. So what happens here? This water molecule, it donates this electron pair to its carbocation and forming a bond between them by, you can see here like this. Okay, so obviously this electron pair, it is donated to this carbon atom, then this oxygen get a positive charge. That means oxygen is electron deficient. And in order to remove this electron deficiency, what happens here is And H2O, which is another one molecule of H2O, it attracts this hydrogen atom towards itself. Thereby, this electron, it is given to this oxygen atom. Thereby, an alcohol is formed here. Is it clear for you guys? That means nothing. We are going to add, okay, what is actually happening here is hydration of alkene in the presence of an acid. So what happens here is this acid here acts as catalyst, and thereby easily a hydronium ion is produced, and this hydronium ion, being it is electron deficient, this this pi bonded character of this C double bond C, it is attacked as a donor, and it donates its electron by accepting a hydrogen. Okay, there you will get a carbocation, and this carbocation will again attract water molecule, and thereby another one OH species is formed, which is of deficient, okay, electron deficient oxygen species is formed. And in order to compensate that, H2O molecule is added to this, and thereby you will get alcohol. Okay, that is the mechanism. I think it's clear for you. Now we are moving to the next slide, and next method, that is hydroboration. Here in hydroboration, BH3, diborane, BH3, B2H6. Actually, diborane, what do you mean by diborane? B2H6. Okay, we are going to boration. We are going to add this group to the alkenes. Okay, we are going to add hydroboration. Okay, hydroboration means it is adding trialkyl borane. Okay, we are going to add trialkyl borane. Okay, we are going to add diborane. Okay, alkenes add diborane to give trialkyl borane as addition product. Thereby you will get an addition product, and this on oxidation by hydrogen peroxide in the presence of aqueous sodium hydroxide to form alcohol. And the net reaction is the addition of water molecule to the alkene in a verb opposite to the Markovnikov rule. So the thing that you have to keep in mind is it is opposite to Markovnikov's rule. It is opposite to Markovnikov.
Okay, ഇനി അടുത്തതായിട്ട് നമുക്ക് അതിന്റെ മെക്കാനിസം നോക്കാം, ഹൈഡ്രോബൊറേഷന്റെ മെക്കാനിസം. സോ ഇവിടെ okay, there you can see an alkene.
What is the name of that alkene? Alkene pair endana.
So the alkene here is, what is the alkene? So the alkene here is propene. Okay, propene. And propene, when it is added to diborane, okay, diborane actually it is B2H6, okay, diborane. Here BH2 is the negative part and H is the positive part, okay, here. And it is according to the anti-Markovnikov's rule. Anti-Markovnikov's rule എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ Markovnikov's rule ന് എതിരായിട്ടുള്ളത്. Okay, that means negative part of the addendum will go to the carbon atom containing more number of hydrogen atom. That is what is called anti-Markovnikov's rule. Negative part go to carbon atom containing more hydrogen atom. Okay. So ഇവിടെ നോക്ക്, ഇവിടെ ഇതാണ് more hydrogen atom ഉള്ളത്. So negative part എങ്ങോട്ട് പോവും? ഇങ്ങോട്ട് പോവും. So you can see here, addition നടന്നു കഴിയുമ്പം ഈ ഡബിൾ ബോണ്ട് ബ്രേക്ക് ആവും, എന്നിട്ട് സിംഗിൾ ബോണ്ട് ആവും, എന്നിട്ട് ഇവിടെ BH2 ഫോം ചെയ്യും. So this according to the anti-Markovnikov's rule. എന്നിട്ട് ഈ CH3, CH ഡബിൾ ബോണ്ട് CH2 പിന്നെയും ഫർദർ ആഡ് ചെയ്യും. അപ്പം മൊത്തം 3 ഹൈഡ്രജൻ ഇല്ലേ? BH3യിൽ 3 ഹൈഡ്രജൻ ഉണ്ടല്ലോ, ആ 3 ഹൈഡ്രജനും നമുക്ക് റീപ്ലേസ് ചെയ്ത് ആൽക്കീൻ കൊണ്ടുവരാം. അപ്പം അതുണ്ടാവും ട്രൈ ആൽക്കൈൽ ബൊറേറ്റ് ഉണ്ടാവും. ഓക്കെ, ട്രൈ ആൽക്കൈൽ ബൊറേറ്റ് ഉണ്ടാവും. ദെൻ അഗെയിൻ നമ്മൾ എന്ത് ചെയ്യും? വിച്ച് അപ്പോൺ ഹൈഡ്രോളിസിസ് നടത്തുമ്പോൾ വിച്ച് അപ്പോൺ ഹൈഡ്രജൻ പെറോക്സൈഡുമായിട്ട് റിയാക്ട് ചെയ്യുമ്പോൾ you will get propanol. Okay, hydrogen peroxide react ചെയ്യുമ്പോൾ you will get propanol. So that is what is about the hydroboration. അപ്പോൾ അതാണ് hydroboration എന്ന് പറയുന്നത്. Now the second method. Okay, now the second method for the preparation of alcohol is from carbonyl compounds. Okay, you can see carbonyl compounds. Carbonyl compounds എങ്ങനെയാണ് പ്രിപ്പയർ ചെയ്യുന്നത്? From carbonyl compounds you can prepare this alcohol by reduction. ഏതൊക്കെയാണ് reduction? Commonly using reducing method ഏതൊക്കെയാണ് എടുക്കാം? Okay, for lithium aluminum hydride അല്ലെങ്കിൽ sodium borohydride ഏത് വേണമെങ്കിലും എടുക്കാം. ഓക്കെ, അല്ലെങ്കിൽ നമുക്ക് കാറ്റലിറ്റിക് ഹൈഡ്രോജനേഷൻ H2 പലേഡിയം കാറ്റലിറ്റിക് ഹൈഡ്രോജനേഷൻ നടത്താം. അല്ലെങ്കിൽ എന്താ ലിത്തിയം അലുമിനിയം ഹൈഡ്രൈഡ് റിഡ്യൂസിങ് ഏജന്റ് ആണ് LiAlH4 ലിത്തിയം അലുമിനിയം ഹൈഡ്രൈഡ്, അല്ലെങ്കിൽ എന്താ സോഡിയം ബോറോഹൈഡ്രൈഡ് NaBH4 ഏത് വേണമെങ്കിലും എടുക്കാം. സോ എടുത്തിട്ട്
reduction. അപ്പോൾ carbonyl compound എടുത്തിട്ട് നമ്മൾ reduce ചെയ്യുമ്പോൾ what you will get the corresponding alcohol കിട്ടും. അവിടെ ഒരു കാര്യം ശ്രദ്ധിക്കേണ്ടത്, aldehydes ആണ്. We are taking aldehydes, then it will give primary alcohol, and if you take ketones, then you will get secondary alcohol. Aldehyde ആണെങ്കിൽ you will get primary alcohol, and ketone ആണെങ്കിൽ you will get secondary alcohol. അപ്പോൾ അത്രയേ ഉള്ളൂ. I will repeat here. Carbonyl compounds like aldehydes or ketones, when reduced using lithium aluminum hydride or sodium borohydride or on catalytic hydrogenation, that means using finely divided metals such as platinum, palladium or nickel. In the presence, hydrogenation നടത്തുമ്പോൾ we get alcohols, and aldehydes give primary alcohol and ketones give secondary alcohol. Clear ആണല്ലോ? Aldehyde ആണെങ്കിൽ primary alcohol തരും, ketones ആണെങ്കിൽ secondary alcohol തരും. Okay, now reduction of carboxylic acid and ester. രണ്ടാമത്തെ reducing. അപ്പോൾ ആദ്യം നമ്മൾ the reduction of carbonyl compounds, അതായത് aldehydes and ketones ആണ് എടുത്തത്. രണ്ടാമത്തെ we are going to take reduction of carboxylic acids and esters. Carboxylic acid, okay, esterification നടത്തുക plus alcohol, you will get an ester, and this is the commercial preparation of alcohol. Okay, commercial preparation ഇതാണ്. So ഇവിടെ എന്താ കിട്ടുന്നത്? You will get an ester, and the ester which upon reduction you will get alcohol. Okay, the ester which upon reduction you will get alcohol. Okay, that is the second method. ഇപ്പോൾ reduction തന്നെ രണ്ട് തരത്തിൽ ഒന്നെങ്കിൽ carboxylic acid അല്ലെങ്കിൽ എസ്റ്ററിനെ reduce ചെയ്യാം, അല്ലെങ്കിൽ reduction of aldehyde അല്ലെങ്കിൽ ketone reduce ചെയ്യാം. Any reducing agent you can use lithium aluminum hydride, sodium borohydride or catalytic hydrogenation, whatever it be. Aldehyde ആണെങ്കിൽ you will get primary alcohol, ketone ആണെങ്കിൽ you will get secondary alcohol, and in the case of acid or ester you will get alcohol, primary alcohol. Okay, now moving to the next method, that is about you can prepare this alcohol from Grignard reagent. How can you prepare this alcohol from Grignard reagent? Nikariam Grignard reagent, what do you mean by Grignard reagent? It is an organometallic compound and it is very important, RMgX. Okay, an alkyl part under, this one is the alkyl part. Okay, this one is the alkyl part. Pinne oru metal under, this one is the metal. Mg, magnesium is the metal, and this one is X. X means halogen part. Mainly this halogen will be satisfied using chlorine iodine, RMgX. Okay, ഈ നമ്മളിപ്പോൾ ഒരു aldehydic or ketone, okay, aldehyde അല്ലെങ്കിൽ ketone എടുക്കുകയാണ്, which means ഒരു carbonyl compound എടുക്കുകയാണ്, അതിലേക്ക് RMgX add ചെയ്യുമ്പോൾ what you will get it is, this R will get attached to this, കാരണം RMgX this one is the negative addendum. So this one is the negative part. So negative part will attach to this carbon. കാരണം the oxygen എന്ന് പറയുന്നത് highly electronegative. So oxygen and the electron അങ്ങോട്ട് വലിച്ചെടുക്കും. So carbon will get a positive charge and oxygen will get a partial negative charge. And in order to satisfy this positive charge of this carbon, what happens? This R, ഇവിടെ nucleophilic addition ആണോ electrophilic addition ആണോ? What do you mean by nucleophilic addition? Nucleus love chain addition. So nucleophilic addition. ഇവിടെ വരും. എന്നിട്ട് what happens here is എന്ത് സംഭവിക്കും? R വന്നിട്ട് ഈ കാർബണുമായിട്ട് അറ്റാച്ച് ചെയ്യും, ടാറ്റക്റ്റ് ഫോം ചെയ്യും. എന്നിട്ട് which upon, അപ്പോൾ ഈ this one is a positively charged particle, അത് എന്ത് ചെയ്യും? ഓക്സിജനുമായിട്ട് അറ്റാച്ച് ചെയ്യും. സോ ഇങ്ങനെ വരും. then upon hydrolysis you will get, ഇവിടെ വെച്ച് ബ്രേക്ക് ആവും, H ഇങ്ങോട്ട് ആഡ് ചെയ്യും, OH ഇങ്ങോട്ട് ആഡ് ചെയ്യും, and you will get MgOHX. and ഇവിടെ ശ്രദ്ധിക്കേണ്ട കാര്യം, ഫോർമാൽഡിഹൈഡ് ആണെങ്കിൽ only formaldehyde will give primary alcohol. ശ്രദ്ധിക്കേണ്ട കാര്യമാണ്, ഇമ്പോർട്ടൻ്റ് ആണ്. ഫോർമാൽഡിഹൈഡ് ആണെങ്കിൽ you will get primary alcohol. ഫോർമാൽഡിഹൈഡ് ആണെങ്കിൽ you will get primary alcohol. വേറെ ഏത് ആൽഡിഹൈഡ് ആണെങ്കിലും സെക്കൻഡറി ആൽക്കഹോൾ കിട്ടും. കീറ്റോൺ ആണെങ്കിൽ you will get tertiary alcohol. കീറ്റോൺ ആണെങ്കിൽ you will get tertiary alcohol. അപ്പോൾ ഫ്രം ഗ്രിഗ്നാർഡ് റിയേജന്റ്, അങ്ങനെയാണ് ഗ്രിഗ്നാർഡ് റിയേജന്റിൽ നമ്മൾ കറസ്പോണ്ടിങ് ആൽക്കഹോൾ പ്രിപ്പയർ ചെയ്യുന്നത്. ഓക്കെ, now moving to the next slide. Okay, now moving to the preparation of phenols. Okay, preparation of phenols. അവിടെ നമുക്ക് മെയിൻലി 4 മെത്തേഡ് ഉണ്ട്. How can you prepare this phenol? From aryl halides. Aryl halides ൽ നിന്ന് we can prepare phenol. Phenolനെ നമുക്ക് aryl halides ൽ നിന്ന് prepare. Okay, അപ്പോൾ aryl halides നിന്ന് prepare ചെയ്യുന്നത് എങ്ങനെയാണെന്ന് ഞാൻ പറഞ്ഞുതരാം. Okay, so here I am going to take an aryl halide, for example chlorobenzene. Aryl halide എന്ന് പറഞ്ഞാൽ എന്താ? ആക്ച്വലി ഹാലോ അരീൻസ് തന്നെയാണ്. ഓക്കെ, ഞാനൊരു ക്ലോറോബെൻസീൻ എടുത്തു. ഓക്കെ, ഈ chlorobenzene is fused with the NaOH. NaOH might fuse ചെയ്യുമ്പോൾ okay, I'm going to fuse the sodium hydroxide with the chlorobenzene at 623 Kelvin. 623 Kelvinilum 300 atm pressureum apply ചെയ്തു. Okay, and you will get what you will get sodium phenoxide കിട്ടും. Okay, sodium phenoxide കിട്ടും. Okay, ONA plus sodium phenoxide കിട്ടി, which upon treating with an acid might treat ചെയ്യുമ്പോൾ what you will get what? This phenol. എന്ത് കിട്ടും? Phenol കിട്ടും. This is the structure of phenol. ഇതാണ് ഫിനോളിന്റെ സ്ട്രക്ചർ. ഓക്കെ, ഒന്നുകൂടെ പറയാം. So the first method, I'm going to change the color of my pen. So the first method, A, from aryl halide, or aryl halide എടുത്തു. Okay, first for example, aryl halide means haloarine, അതായത് chlorobenzene. Okay, I'm going to take a chlorobenzene എടുത്തു. And then chlorobenzene, when it is fused with the sodium hydroxide, NaOH ആയിട്ട് treat ചെയ്തു. We are applying high temperature and pressure, for example 623 Kelvin and 300 atm pressure apply ചെയ്തു. Then you will get a sodium phenoxide ion. Okay, sodium phenoxide ONA minus. Okay, ONA plus O minus Na. This is sodium phenoxide. Sodium phenoxide, which is not stable. Okay, sodium phenoxide. And when this treated with acid, when I'm going to treat it with acid, what you will get? Our phenol, corresponding phenol. So that is the method, that is the first method, that is preparation of phenol from aryl halides. How can you prepare from aryl halides? Okay. Now moving to the second method, I'm going to change the color of my pen to blue. Okay, from benzene sulfonic acid. Okay, first of all you have to prepare this benzene sulfonic acid. How can you prepare this benzene sulfonic acid? Easy. And the sulfonation നടത്തിയാൽ മതി, benzene ring എടുത്ത് sulfonation നടത്തുക. So I'm going to conduct the sulfonation at first. So I'm taking a benzene ring. So this one is a benzene ring. Sulfonation വേണ്ടിയിട്ട് ഞാൻ oleum എടുക്കുക, H2S2O7. Okay, H2S2O7 oleum എടുത്തു. Okay, I'm going to sulfonate it and you will get what you will get? Benzene sulfonic acid. This one is benzene sulfonic acid, that is SO3H attach ചെയ്തു. And again it is converted to sodium phenoxide. നമ്മൾ ഈ മേളിൽ കണ്ട sodium phenoxide ആയിട്ട് convert ചെയ്യും when you are adding some sodium hydroxide. Sodium hydroxide കിട്ടുമ്പോൾ മേളത്തെ sodium phenoxide കിട്ടും. ആ sodium phenoxide നെ പിന്നെ acidify ചെയ്യുമ്പോൾ what you will get? അപ്പോൾ ഞാൻ ഒറ്റ സെന്റൻസിൽ ഒറ്റ റിയാക്ഷൻ എഴുതുകയാണ്, what you will get? Phenol കിട്ടും. So ഒന്നുകൂടെ പറയാം, I will tell you the reaction once more. ആദ്യം you have to take from benzene sulfonic acid and preparation of phenol. First of all you have to take a benzene. Benzene sulfonation നടത്തി you will get benzone sulfonic acid. ആ benzene sulfonic acid you have to convert it into sodium phenoxide by in the presence of sodium hydroxide, and which upon acidification you will get what you will get? Phenol. This one is phenol. Okay, ഈ രണ്ട് മെത്തേഡും ഈസിയാണ് കേട്ടോ. ആദ്യമേ ഹാലോ അരീൻസിൽ നിന്ന് അല്ലെങ്കിൽ അറയിൽ ഹാലൈഡിൽ നിന്ന് സോഡിയം ഹൈഡ്രോക്സൈഡ് അവിടെയുണ്ട്. ആളാരാ? സോഡിയം ഹൈഡ്രോക്സൈഡ് അവിടെയുണ്ട്. സോഡിയം ഹൈഡ്രോക്സൈഡ് ആണ് നമ്മുടെ ഇവിടുത്തെ താരം. സോഡിയം ഹൈഡ്രോക്സൈഡ് സോഡിയം ഹൈഡ്രോക്സൈഡ് ഇവിടെയുണ്ട്. സോഡിയം ഹൈഡ്രോക്സൈഡ്. അങ്ങനെ നമ്മൾ എന്താ ഉണ്ടാക്കുന്നത്? സോഡിയം ഫിനോക്സൈഡ് ഉണ്ടാക്കുക. ഓക്കെ, വാട്ട് യു വിൽ ഗോയിങ് ടു പ്രിപ്പയർ? വി ആർ ഗോയിങ് ടു പ്രിപ്പയർ sodium phenoxide. Sodium phenoxide, which upon hydrolysis acidification you will get phenol. Then the next method, that is third method. Okay, I'm using green color. Okay, from diazonium salt. Okay, first of all you are going to prepare a diazonium salt. So നിങ്ങൾ diazonium salt എങ്ങനെ prepare ചെയ്യുന്നു നോക്കാം. For that you are going to take aniline. Okay, aniline എന്ന് പറഞ്ഞാൽ benzene ringil NH2 group attach ചെയ്ത് കഴിഞ്ഞാൽ you will get aniline. So you are going to take aniline, and which upon treating with NaNO2, sodium nitrate, plus HCl, what happens? Benzene diazonium chloride കിട്ടും, that is N2Cl. ഇതാണ് benzene diazonium chloride. അപ്പോൾ എങ്ങനെയാണ് benzene diazonium chloride കിട്ടുന്നതെന്ന് മനസ്സിലായോ? എങ്ങനെ? അനിലിൻ എടുത്തിട്ട് NaNO2 in the presence of HCl ട്രീറ്റ് ചെയ്യുമ്പോൾ എന്ത് കിട്ടും? benzene diazonium chloride കിട്ടും. നിങ്ങൾക്ക് വേണം ക്ലോറൈഡ് വേണം, അപ്പോൾ നമുക്ക് HCl ഒഴിക്കണം. ഡയസോണിയം വേണം, അപ്പോൾ അനിലിൻ N2. ഓക്കെ, സോ benzene diazonium chloride കിട്ടി. അതിനെ എന്ത് ചെയ്യണം? You have to warm H2. You have to warm in the presence of water. Then you will get what you will get? Phenol. So diazonium salts are hydrolyzed to phenols by warming with the water or by treating with a dilute acid. N2 with HCl with them. So this is the third method, that is from diazonium salt. So from aryl halide from benzene sulfonic acid then from diazonium chloride, diazonium salt okay, diazonium chloride. Next, this one is the commercial preparation, that is from cumin. So cumin endannu. Okay, cumin, I'm going to change the color. Okay, I'm going to erase all these. Okay, the last method is how can you prepare this phenol from cumin. Okay, I will show you. So from cumin, what do you mean by cumin? Cumin is actually isopropyl benzene. Okay, isopropyl benzene. Isopropyl benzene എന്ന് പറഞ്ഞാൽ ഒരു isopropyl group benzene ringിലേക്ക് attach ചെയ്തിരിക്കുക. For example, നമ്മുടെ benzene ring ആണ്. I'm going to draw this isopropyl ring. Okay, this one. Simple ആയിട്ട് പറഞ്ഞു കഴിഞ്ഞാൽ ഇങ്ങനെ അത് കാർബൺ വെച്ചിട്ട് എലാബറേറ്റ് ചെയ്ത് കാണിക്കുകയാണെങ്കിൽ ഒരു മിനിറ്റ്. So this one is CH3, this one is CH3 and this one is CH. Okay, CH. Okay, ഒന്നുകൂടെ എഴുതി കാണിക്കാം. I will. Okay. So color use ചെയ്യാം B. Okay. So അപ്പോൾ ഇവിടെ എന്ന് വെച്ചാൽ ഒരു isopropyl group CH3, CH3. This isopropyl group is attached to this benzene ring. ഈ benzene ringിലേക്ക് attach ചെയ്ത് വെച്ചിരിക്കുക. This is actually cumin. ഈ cumin which upon ഈ cumin നമ്മൾ എന്ത് ചെയ്യാൻ പോവാ? ഓക്സിഡേഷൻ നടത്താൻ പോവാം. O2. ഓക്കെ, അപ്പോൾ നമുക്ക് എന്ത് കിട്ടും? ക്യൂമീൻ ഹൈഡ്രോപെറോക്സൈഡ് കിട്ടും. ക്യൂമീൻ ഹൈഡ്രോപെറോക്സൈഡ് എങ്ങനെ എഴുതുന്നത്? വളരെ എളുപ്പമാണ്. CH അല്ലേ നമ്മളിവിടെ എഴുതിയേക്കുന്നത്, അതിനിടയ്ക്ക് ഒരു O2 അങ്ങോട്ട് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്ത് കൊടുക്കുക, എന്നിട്ട് ബാക്കിയെല്ലാം അതുപോലെ തന്നെ കിട്ടും. ഇതാണ് ക്യൂമീൻ ഹൈഡ്രോപെറോക്സൈഡ് എന്ന് പറയുന്നത്. ഓക്കെ, അപ്പോൾ എന്താ സാധനം? ക്യൂമീൻ ഹൈഡ്രോപെറോക്സൈഡ്. അപ്പോൾ എന്താ നമ്മൾ ആദ്യം ചെയ്തത്? ആദ്യം ക്യൂമീൻ എടുത്തു, ഈ ക്യൂമീനെ O2 വെച്ച് ആഡ് ചെയ്തു. ദാറ്റ് മീൻസ് ഒരു ഹൈഡ്രോപെറോക്സൈഡ് റിംഗ്, ഓക്കെ, ഒരു ക്യൂമീൻ ഹൈഡ്രോപെറോക്സൈഡ് ഫോം ചെയ്തു. Okay, then again it is converted to phenol and acetone by treating it with a dilute acid. Again, നമ്മൾ ഇതിനെ ആസിഡ് വെച്ച് ട്രീറ്റ് ചെയ്യാൻ പോവാണ്. Now we are going to treat this cumin hydroperoxide with acid, that is H plus bar H2O. At that time what you will get? Phenol കിട്ടും. You will get phenol and also CH3CO, CH3, that is what is called acetone. So you will get acetone and phenol. Okay, ഇവിടെ acetone എന്ന് പറയുന്നത് it is a byproduct obtained from this reaction with phenol. Phenolന്റെ കൂടെ കിട്ടും, and it is also obtained in large quantities by methods. അപ്പോൾ this method can be used for the preparation of acetone also. അപ്പോൾ എന്താ നമ്മളിവിടെ ചെയ്തത്? Taking cumin subjected to oxidation, you will get cumin hydroperoxide, and again this cumin hydroperoxide undergo acidification, you will get phenol and acetone. You will get acetone production കൂടുതലായിരിക്കും. So you can also use this method for the production of acetone also. Okay. Phenol മാത്രം ഒന്ന് കൺക്ലൂഡ് ചെയ്യാം. ഓക്കെ, അപ്പോൾ അതിന് മുമ്പ് ഞാനൊരു കാര്യം പറയട്ടെ. ദിസ് ഫിനോൾ ക്യാൻ ബി ഓൾസോ കോൾഡ് ആസ്, ഓക്കെ, വാട്ട് യു ക്യാൻ ബി കോൾഡ് ഫിനോളിന് അറിയപ്പെടുന്ന വേറൊരു പേരാണ് കാർബോളിക് ആസിഡ്. ഓക്കെ, ഇപ്പോൾ ഫിനോളിന് അറിയപ്പെടുന്ന വേറൊരു പേരാണ് കാർബോളിക് ആസിഡ്. ഓക്കെ, ജസ്റ്റ് ഞാനൊന്ന് മെൻഷൻ ചെയ്തതേ ഉള്ളൂ. ഓക്കെ, സോ ജസ്റ്റ് നമുക്ക് ആ 4 പ്രിപ്പറേഷൻ ഒന്ന് നോക്കാം. സോ ദ ഫസ്റ്റ് മെത്തേഡ് ഈസ് ഫ്രം ഹാലോഅരീൻസ്. അപ്പോൾ ഹാലോഅരീൻസ് എങ്ങനെയാണ്? ബെൻസീൻ ക്ലോറൈഡ്, ഫോർ എക്സാമ്പിൾ നമ്മളൊരു ബെൻസീൻ ക്ലോറൈഡ് എടുത്തു, എന്നിട്ട് നമ്മളത് NaOH ആയിട്ട് ട്രീറ്റ് ചെയ്തു അറ്റ് എ ഹൈ പ്രഷർ ആൻഡ് അറ്റ് എ പർട്ടിക്കുലർ ടെമ്പറേച്ചർ. നിങ്ങൾക്ക് സോഡിയം ഫിനോക്സൈഡ് കിട്ടും. ആ സോഡിയം ഫിനോക്സൈഡിനെ, ഫോർ എക്സാമ്പിൾ ONA, ആ സോഡിയം ഫിനോക്സൈഡിനെ പിന്നെ അഗെയിൻ വെൻ ട്രീറ്റഡ് വിത്ത് ആസിഡുമായിട്ട് ട്രീറ്റ് ചെയ്യുമ്പോൾ NA മാറിയിട്ട് what you will get? Phenol കിട്ടും. Okay, now the second method is, okay, OH. Now the second method is from benzene sulfonic acid. Okay, from benzene sulfonic acid. For that ആദ്യം നിങ്ങൾ benzene sulfonic acid ഉണ്ടാക്കണം. So how can you prepare benzene sulfonic acid? ആദ്യം benzene എടുത്തിട്ട് അതിനെ സൾഫനേഷൻ നടത്തി കഴിയുമ്പോൾ benzene sulfonic acid കിട്ടും. Okay, sorry. So, oh sorry, 1 minute. Control 2. Okay, benzene എടുത്തു. Okay, second method is benzene എടുത്തു. benzene എടുത്തിട്ട് okay sorry benzene എടുത്തു okay benzene you're going to sulfonate it okay you're going to sulfonate that means NaNO sulfonate okay എന്ത് വെച്ചിട്ടാണ് നമ്മൾ oleum വെച്ചിട്ട് okay oleum വെച്ച് sulfonation നടത്തി so you will get benzene sulfonic acid കിട്ടി SO3H okay benzene sulfonic acid കിട്ടി എന്നിട്ട് എന്ത് ചെയ്യും this benzene sulfonic acid നെ നമ്മൾ നേരത്തെ ചെയ്ത പോലെ സോഡിയം ഹൈഡ്രോക്സൈഡ് വെച്ച് NaOH വെച്ച് ട്രീറ്റ് ചെയ്തു അപ്പോൾ നിങ്ങൾക്ക് സോഡിയം ഫിനോക്സൈഡ് കിട്ടും ആ സോഡിയം ഫിനോക്സൈഡിനെ തന്നെ HCl ഒരു ആസിഡിക് മീഡിയത്തിൽ ട്രീറ്റ് ചെയ്യുമ്പോൾ what you will get ആ സോഡിയം ഫിനോക്സൈഡ് എന്ന് പറയുന്നത് മാറിയിട്ട് ഫിനോൾ കിട്ടും okay so that is the second method preparation of phenol from benzene sulfonic acid. Then the third method is from diazonium salt. അപ്പോൾ how can you prepare diazonium salt അത് പറഞ്ഞുതരാം ആദ്യം അനിലിൻ എടുത്തു NH2 okay അനിലിൻ എടുത്തു എന്നിട്ട് ട്രീറ്റിംഗ് വിത്ത് NaNO2 okay sodium nitrate NaNO2 in the presence of HCl. അപ്പോൾ ശരിക്കും നിങ്ങൾക്ക് കിട്ടുന്നത് എന്താ ഇവിടുന്ന് നൈട്രസ് ആസിഡ് ആണ് കിട്ടുന്നത് ഓക്കെ നൈട്രസ് ആസിഡ് ആണ് ഇവിടെ കിട്ടുന്നത് ഓക്കെ നൈട്രസ് ആസിഡ് കിട്ടും അപ്പോൾ എന്ത് കിട്ടും ബെൻസീൻ ഡയസോണിയം ക്ലോറൈഡ് കിട്ടും സോ ബെൻസീൻ N2Cl ഓക്കെ ബെൻസീൻ ഡയസോണിയം ക്ലോറൈഡ് കിട്ടും ഈ ബെൻസീൻ ഡയസോണിയം ക്ലോറൈഡിനെ പിന്നെ വെള്ളം ഒഴിച്ച് വാം ചെയ്യുമ്പോഴേക്കും വാട്ട് യു വിൽ ഗെറ്റ് ഫിനോൾ കിട്ടും ഫിനോളും അതിൻ്റെ കൂടത്തി നൈട്രജൻ ഗ്യാസും പിന്നെ അതുപോലെ തന്നെ HClഉം കിട്ടും നൈട്രജൻ ഗ്യാസും പിന്നെ HClഉം കിട്ടും then last method that is from cumin എന്താണ് ഐസോപ്രോപ്പൈൽ ബെൻസീൻ ആണ് cumin okay ഐസോപ്രോപ്പൈൽ ബെൻസീൻ ആണ് cumin CH ഇവിടെ CH3 ഉണ്ട് കേട്ടോ ഐസോപ്രോപ്പൈൽ ബെൻസീൻ അതിനെ നമ്മൾ ഓക്സിഡേഷൻ നടത്തി അപ്പോൾ what you get ഐസോപ്രോപ്പൈൽ ബെൻസീൻ പെറോക്സൈഡ് കിട്ടും okay that means cumin ഹൈഡ്രോപെറോക്സൈഡ് കിട്ടും cumin ഹൈഡ്രോപെറോക്സൈഡ് ഇവിടെ ഒരു CH3 ഉണ്ട് മുകളിൽ ഒരു CH3 ഉണ്ട് ഇവിടെ OH വന്ന് സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യും ദാറ്റ് ഈസ് cumin ഹൈഡ്രോപെറോക്സൈഡ് ഈ cumin ഹൈഡ്രോപെറോക്സൈഡിനെ then what you will get എന്ത് ചെയ്യും ഓക്കെ H plus bar H2O നടത്തുമ്പോൾ you will get ഫിനോൾ ഞാൻ ഇവിടെ OH എഴുതി എങ്ങനെ എഴുതിയാലും കുഴപ്പമില്ല പ്ലസ് അസറ്റോൺ ഇവിടെ അസറ്റോൺ കൂടുതൽ പ്രിപ്പയർ ചെയ്യുന്നുണ്ട് ദിസ് മെത്തേഡ് ഈസ് ഓൾസോ യൂസ്ഡ് ഫോർ ദ പ്രിപ്പറേഷൻ ഓഫ് അസറ്റോൺ ഓക്കെ സോ ദാറ്റ്സ് ഓൾ ഫോർ ടുഡേ ഇന്നത്തെ ദിവസത്തേക്ക് ഇത് മാത്രമേ ഉള്ളൂ okay so hope you like this video and also thank you all if you found this video useful please share among your friends okay thank you